In this video, we will be learning how to classify polynomials by both degree and type. So before we talk about polynomials, we actually have to talk about what's called a monomial first, because polynomials are built by using monomials. So a monomial is a number, a variable, or the product of numbers and or variables. So that's what a monomial is by definition. So what we're going to do down below is we're going to go through the 4 different expressions that you see, and we're going to decide if it's a monomial or it is not a monomial. And we're just going to use the definition to do that. So the first one here, we see 10. And we see in our definition that a monomial is a number, a variable, or the product of numbers and variables together. Well, if we look carefully here, what we notice is that 10 is a number. So 10, yes, is a monomial. Then if we look at the second one here, we see 5 plus x. And if I look up above, yes, monomials can use numbers and variables, but this word product, remember, product means multiplication. So if we have a monomial with both numbers and variables, they need to have multiplication going on, which this has addition, so it is not a monomial. Then from here, the next one we have is negative 1.8 m to the 5th. Now I know because those two are smushed together, this is really negative 1.8 times m to the 5th. So that is meeting the whole numbers, variables, multiplication piece. And then really, if I break up that m to the 5th, I know that m to the 5th is really m times m times m times m times m. So that's really a bunch of numbers and variables all being multiplied together, which means that it meets the definition of monomial, and as a result, it is one. Then this next one here, I see 2 over n. Well, already I can see that this is division. It's not multiplication between numbers and variables, so I can already say that is not a monomial. The next one down here, I see 1/2. Remember, 1/2 is just the number 0.5. So this is really saying 0.5 times a times b, which is the multiplication of numbers and variables. So this is in fact a monomial. Here in this next example, we have 3 times x. That's the multiplication of numbers and variables. So that is a monomial. Then this next one here, while it looks like a monomial, if we get rid of that negative exponent using the exponent properties that we know that this really means 1 over x to the power of 1, which is division between numbers and variables, and as a result, this is not a monomial. And then this last one here, we have a variable and a number, but what's different here is that the variable is what's in the exponent, and this variable in the exponent, since we don't know exactly what that variable's value is, and it's not the multiplication between a number and a variable, this is not a monomial. Now, beyond just being monomials, every single monomial has what's called a degree. And the degree of a monomial is the sum of the exponents of the variables contained in the monomial. So then this last part says the degree of a non-zero constant term. So that means like this right here, where there's no variable. The degree of something with no variable term is simply 0. So here for this 10, because it's a non-zero constant term, essentially saying it doesn't have a variable, this is a 0th degree monomial. Then if I look at the next one, I notice I have a number times, and then I have a variable with an exponent of 5. So this is a 5th degree monomial. Then if I look at the next one, I notice that I have a to the first power and b to the second. Since I have two variables with two powers, I add them together, which ends up being 3, and as a result, this third expression is a third degree monomial. Then if I look down here at the next example, what I notice is I have 3 times x, and I know that x has a power of 1, and that's the only variable there, so this is a first degree monomial. And then if I look at that next one, I see that I have 3 variables with 2, 5, and 3. 2 plus 5 is 7, plus 3 is 10. So this is a 10th degree monomial. So now that we understand what a monomial is, we can move on and talk about a polynomial. And a polynomial is a monomial, so it can be what we just defined, or the sum of monomials. Notice the plural. The sum is the adding of monomials, each of which is called a term of a polynomial. So we're either going to have one monomial, or we're going to have a bunch of monomials added or subtracted together. So what we're going to do down below is we're going to look at each single polynomial, or what we think is a polynomial, and we're going to decide if it is in fact a polynomial. Now the key here with a polynomial is every term is a monomial. So it needs to meet the requirements of a monomial, which, if you remember, is a number, variable, or the product of numbers and variables. So we're going to look at each term down below, and if one term does not meet the requirements of a monomial, the whole thing cannot be a polynomial. So here, if we look at this first example, I'm going to look at each term one at a time. So if I look at the first term, what I see is 6 times n to the power of 4. So this is really 6 times n times n times n times n. That does meet the requirements of a monomial, so this one is good to go. But then if I look at the next one, what I notice is that I have a variable in an exponent. A variable in an exponent is not considered a monomial. And as a result, because I have one term that is not a monomial, this entire thing cannot be a polynomial. Now if I go and look at the next example, I see 2 times x. So this is a monomial. Just an x is just a variable. That's a monomial. And this is really a -5. So that is a monomial. And as a result, because they are all monomials, this entire thing is in fact a polynomial. It has many monomials being added together. Then if I look at this next example here, what I notice is I have a negative exponent, and I remember that this is really written down in the denominator. So this really becomes 1 over n squared, which is the division of a number and a variable. And as a result, automatically, I don't need to check anything else because this doesn't meet the requirements of a monomial. This entire thing cannot be a polynomial. Then next I notice that I have just 9, and just 9 is a monomial because it's a number. And then remember that just a monomial by itself qualifies as a polynomial. So as a result, this is a polynomial. Then if I look at this next example, this is 7 times b times c times c times c. Well, that is in fact a monomial. And then I have 4 times b times b times b times c. That is a monomial. And since I have two monomials being added together, that is in fact a polynomial. And then lastly here, what I notice is that I have a big division problem going on. And this big division problem is basically showing me that it is not a polynomial already off the bat. A polynomial is the sum of monomials, and here I've got a big division problem in it. which we know automatically disqualifies it from being a monomial. So this one is not a polynomial. So now that we understand what a polynomial is, we're going to look at the degree and the leading coefficient of what are called polynomials. So we're going to start here. The degree of a polynomial is the highest degree of all of its terms, or of all of its monomials that it has being added together. So when we find the degree of a polynomial, we are looking for the highest monomial term. So we're going to look at each term one at a time, find its degree, and then that is the degree of the polynomial that we have. So notice this is a little bit different than when we did monomials. Monomials, we added together all of the exponents of the variables. Now we're going to look at each monomial by itself and find the highest one. So if I look at this first example here, this has an exponent of 1, this one has an exponent of 6, 4, and because there's no x here, this one is 0. So of these four numbers, I notice that 6 is the highest degree term that I have. And as a result, this is a 6th degree polynomial. So in addition to understanding the degree of a polynomial, we also need to talk about what the leading coefficient of a polynomial is. Now, coefficient is a word you should already know. Coefficient is the number in front of a variable. So every single term that contains a variable will have a coefficient. And specifically here, we're going to focus on what's called the leading coefficient. So this is a specific type of coefficient. And this is the coefficient of the first term when a polynomial is written so that the exponents decrease from left to right. So basically the degrees decrease from left to right. So as I look at this first example here, what I notice is that the degrees for my three monomial terms are 1, 7, and 0. So as a result, I'm going to rewrite this so that all of its exponents, or its terms, decrease from the highest degree term to the lowest degree term. So because 7 is the highest, I'm going to write this first to be 4x to the 4th. Plus, second, I see I have a degree of 1. So negative 2x. And third, I have plus 3. So once I've written them so the exponents are decreasing from left to right, my leading coefficient is the coefficient of the first term. So this 4 here would be known as my leading coefficient, essentially my first coefficient when my polynomial is written from highest degree to lowest degree. Now if I look at my next example, I'm going to go through the same process. So first I'm going to go through and add in my coefficients to make sure I can see what they all are. So that I added in a 1, then I'm going to utilize keep, change, change. So then from here I know I want to rearrange these so that they are in decreasing order from highest degree to lowest degree. So this monomial has a degree of 6, this monomial a degree of 9, and this one a degree of 1. So my degree of 9 needs to come first, so I have negative 1x to the power of 9. Then plus, my degree of 6 comes second, so negative 2x to the 6th. And then my degree of 1 comes third. And then I look here for my leading coefficient, and my leading coefficient is the number that's in front of the first term, which here is negative 1. So my leading coefficient is negative 1. Coefficient, there we go. So now that we have all of this knowledge, we're finally going to tackle the learning target from the first slide. We have multiple types of polynomials, and polynomials are classified by using both their number of terms and their highest degree. So what we're going to do here is we're going to talk through the special names for the number of terms, and then we're going to classify 5 different polynomials. So first thing we need to know is that the terms for a polynomial, a one-term polynomial, so where it has one item, is called a monomial. A two-term polynomial where there are two things being added together is called a binomial. And that word bi is kind of familiar. You can think of a bicycle has two wheels, so that's kind of where that term comes from. Then a three-term polynomial is a trinomial and kind of similar to a bike. You have a tricycle, which has three wheels, so that's where that word comes from. And then more than three, we typically just call a polynomial. And we do this because beyond three, we really are just talking poly and meaning many terms being added together. So here, if we look down below, we're going to name the following 5 polynomials, specifically using their number of terms and their highest degree. So if I look at this first one, if I look at degree, I notice that we have a 7, a 1, and a 0 degree. So I take the highest degree to classify my polynomial. So this is going to be a 7th degree polynomial. And specifically, it has 1, 2, 3 terms, which is called a trinomial. So this is a 7th degree trinomial. If I then look at the second example, what I see here is I have degrees of 4 and 0. My highest degree is 4, so I know that this is a 4th degree. And then I notice 1, 2 terms, which relates to binomial. So this is a 4th degree binomial. Then I look at the next one and I see I have degrees of 5, 3, and 2. 5 is my highest, so this is a 5th degree. And then I see 1, 2, 3 terms being added together, so it's a trinomial. Then again, the next one, I notice that I have degrees of 9, 6, and 1, with 9 being the highest. So here I have a 9th degree. And then 1, 2, 3 terms being added, so it's a trinomial. And then finally, in my last example, I notice here that this does not contain a variable, so it's a 0th degree polynomial. And specifically, because there's only one term, it is a monomial. So we're using our knowledge of number of terms and what those are specifically called, as well as the highest degree, to accurately classify all of these polynomials.